everyone.
Good morning, ma'am.
Good morning, ma'am.
Good morning, ma'am.
Okay, so in the last class, we have seen two possibilities in how to use, constant keyword, whether to use constant keyword or not in front of pointer or constant data, right? So, what are the two possibilities that we have seen? What are the two possibilities? The first possibility that we have seen is non-constant pointer to non-constant data. Yes, and the second one is non-constant pointer to, just a minute, yeah, non-constant pointer and non-constant data, right? When to use this? This is the highest level of privilege. When to use this? Any idea?
Ma'am, when we have to take the input.
When we have to modify the data or when the caller function, okay, the called function actually, when the called function have to modify the data as well as the pointer. When the modification of both of these things are required, then we will pass non-constant pointer to non-constant data. Okay, because in this, whatever we are, talking about is what are the privileges that we can give to call function, right? Then we have seen if we want that the data, the actual data that cannot be modified, only we want to modify the pointer location, okay, the address to which or the location to which it is pointing to, we want to modify that only, then we will use non-constant pointer to constant data, right? And we have seen in the example that if we try to modify this data, then you will get error. If you modify the pointer location, then there is no problem, okay? And this is the example of that. If we are trying to modify this, if we are trying to modify the data to which the pointer is pointing to, then we will get the error. Okay, so if you are passing non-constant pointer to constant data, then you cannot modify the value that is stored on the location. You can only modify the pointer itself. Okay, so in this example, if suppose so here we are passing f of at the rate y, and here we are taking it into x pointer. So it is allowed to change x pointer, it is allowed, okay, but you cannot change asterisk x pointer because this is dereferencing to the pointer. This is referred to the value of the pointer. That value you cannot change because you are passing a constant data, right? So till this point we have looked at. Now let's see, how is it possible to and we have seen that if the memory is low and execution efficiency is a concern, then use pointers because there is no need to make another copy of the object. If the memory is abundance, right, and efficiency is not a major issue, it is allowed to make the copy. Just pass the data by value to enforce the principle of least privilege. And in this, the called function cannot modify the original value. Okay, but if you want to use both of this, then you can use accordingly the constant keyword. Okay, so I mean, depending upon the situation, you can either use constant or not use constant. Now let's have a look at opposite scenario where we will use constant pointer but non-constant data. Okay, data is non-constant, right? Constant pointer to non-constant data. Now, constant pointer to non-constant data always point to same memory location, okay, because our pointer is constant. You cannot change the pointer the memory address that is stored at the pointer. You cannot change that address. Okay, the only thing that you can change is the data which is stored at that location. Okay, that can be modified. So in our previous example, if we see xptr is equals to 100, yes, now this is allowed. Okay, but if you want that xptr will now point to some other variable, this is not allowed. Okay, and this is the default setting when we pass array name in the function argument, as the function argument, right? So array name is a constant pointer. The function cannot change the array name. Okay, so what is array name actually? We have already seen that array name is nothing but it is the pointer, or it is the address, okay, of the first location where the arrays start storing. Okay, so our array start from a, right? So this particular location, suppose 0001, then array name, suppose a is the name of the array, then array name will actually pointing to this location, and the function is not allowed to change that location. Okay, so this is the by default setting. We can change the elements of the array which are stored, but you cannot change the uh, array address that it is pointing to. Okay, it will always point to this location. So all data in the array can be accessed and changed by using array name and subscript, but a constant pointer to non-constant data can be used to receive an array as an argument to the function that access array element using only array subscript notation, right? Any question here? Array name will always point to first location of the array. Okay, this is fixed, and this is a setting called constant pointer to non-constant data. Okay, and if you explicitly want this type of setting, this is the by default setting for arrays, right? But if you are making some other variable and you would like to have such type of setting, now in that case what you have to do, you have to define your pointer like this. Okay, int star constant and name of the pointer. Suppose ptr is the name of the pointer. Okay, now if you remember that when we are passing the constant data, okay, we are writing like this: constant int star x pointer, which means, and how we will read this, that x pointer is a pointer of integer constant. Okay, now when you want to make a pointer constant, then remove this word constant from here and you have to put it somewhere here in this way. Okay, so suppose the pointer name is ptr. So ptr is a constant pointer to integer type. Okay, so always read it from right to left, and then you will not face any difficulty in where to put this constant, right? So if the constant is along with the pointer name, then we will say that this is a constant pointer. If the pointer is with the data type, then we will say this is we are talking about constant data, right? So we will write it in this way and we will read it as pointer is a constant pointer to an integer. Now whenever we are making constant pointer, please remember that we have to initialize it with the address of the integer. Okay, and how we are doing it, so let's see the program. Yes, so this is the way to pass a constant pointer to non-constant data. So here we are defining, suppose, two variables x and y. Okay, and then we are defining a constant pointer to integer, and the address to ptr is this, right? So now what actually we are doing is we are saying that ptr is a pointer, x is a variable, and y is also a simple variable of integer type. And then we said that this ptr is pointing to x in this line, right? And the value to x is 7. So we are setting the value using this line. Okay, so this is allowed because this is a non-constant data. Now when if we write this particular line, ptr is equals to at the rate y, means what we are saying, we say that now the pointer should point to this address. Now this is not allowed because this is a constant pointer. Once the value is assigned to this variable, you cannot change the value. Okay, so this line will give error, and it is some sort of same error that we have received when we are changing value of constant data. Any question in this?
हम इसे एज अ फंक्शन में नहीं कर सकते हम, मतलब जैसे हम बाकी में दोनों में कर रहे थे.
You can do it in a function, right? So in that case, let me see if there is any example of that. I think not. Okay, so what you will do to pass it in a function? Suppose this is a function call. Okay, fun is a function call. So you have to declare this pointer variable in this way, int star constant, right? And then the value, and your function will start. Okay, no problem. But when you call the function, what you have to pass? Address of some variable, suppose x. Okay, so this is the calling of the function, and this is the declaration of the function. Okay, so
Okay,
when this line execute for the first time, when this function will get called, what happened? The value of this ptr will become address of x. And within the function, now you cannot change. You can change the value that is stored on x, but you cannot change the value to which pointer is pointing to. Okay, so this line is allowed, but this line is not allowed. Any other question? Okay, now let's see constant pointer to constant data. Okay, so this is the least privilege that is granted to any function. The highest privilege is non-constant pointer to non-constant data. You can, the called function can modify the data also and the pointer also. This is the highest privilege. And the least privilege is, you cannot modify anything. I am just giving you to use it, to access it, but you are not allowed to modify anything. So this is called the least privilege. Okay, so such a pointer is always point to same memory location, and the data at that memory location also cannot be modified. Okay, so both of this will remain same. The memory location will also be same, and the data is also cannot be modified. And this is how an array should be passed to a function that only looks at the array using subscript notation and does not modify the array. Okay, so by default setting of array is you cannot modify the array name or the address to which the array name is pointing to, but you can modify the data. If you want that the called function will not modify the data of the array also, then you have to go for this particular setting. Okay, constant pointer to constant data. And if you want both things to be constant, you have to use two constant keywords. Okay, so if we declare our pointer in this way, how we will read it? That pointer is a constant pointer to an integer constant. Okay, so you have to use constant keyword two times. Now let's see, there is an example. So x is initialized with 5. Okay, there is another variable y. Okay, now the pointer I am making is such that the pointer is also constant and the data is also constant. Okay, so not neither this particular line is allowed nor this particular line is allowed. Okay, once it is done, it is done. You cannot modify it. So you have to remember, whenever you are making the data as a constant, you should initialize it. Similarly, whenever you are making the pointer as a constant, you should initialize it. Okay, because if it is not done, then you cannot change the value in future. Okay, so suppose if we don't do initialization here, we are not allowed to do it any further. Okay, so please remember to initialize it. Any question? Yes, no? So these are the four possibilities that we have seen when we can use constant keyword along with the pointer. Okay, non-constant pointer, non-constant data, non-constant pointer with constant data, constant pointer with non-constant data, and both the things are constant. Okay, all right. Now let's again have a look at the bubble sort that we have already seen. And now we will try to use all the concepts that we have learned till now. Okay, so do you remember how we have seen this bubble sort? What we did in bubble sort? What is bubble sort? Yes,
Comparing elements of array means consecutive elements of array.
right. So we would like to sort the given array. And what bubble sort algorithm will do? Bubble sort algorithm will compare two consecutive elements. If we want to sort elements in ascending order, okay, then what bubble sort will do? Bubble sort will compare two consecutive elements, and if the first element is greater, then there is a swapping. Okay, and we will keep doing this until the end of the array will come, and this is called one pass. Remember, in the second pass again we will start doing the same thing. Okay, we will look at the consecutive elements and keep doing this. So one pass is required. I mean, in one pass at least one element will be at its right location, either the largest one or the smallest one, depending upon which type of sort we are using, ascending or descending. Okay, and how many passes are required?
N minus 1.
N minus
N
1.
minus
Right, n minus 1 passes are required. And in one pass, how many comparisons are required?
N minus
N
1.
minus 1.
Comparisons. Okay, in each pass. In each pass. This is also important. All right. So I hope that you all remember this bubble sort. Now let's see how we can use or how we can improve this bubble sort program using functions and our pass by reference concept along with the constant type concept, right? Okay. So now what we will do is we will make a bubble sort function, and that bubble sort function will actually call swap function. Now what this swap function will do? Okay, one more important thing I would like to revise. Whenever we pass an array, by default array is passed by
reference.
passed by
Reference.
reference. But when you will pass one element of the array, it is one element is
Pass by value.
passed by value. Okay, this we have already seen, but just to revise that if you will, we will talk about one element, it is passed by value. But if you will pass entire array by array name or first index, it is passed by reference, right? Okay. So now what we will do, we will make two functions, bubble sort function and swap function. So bubble sort function will actually call swap function. What swap function will do, actually swap function will exchange the element, consecutive element if required, right, depending upon the condition. Okay, now bubble sort, in bubble sort we will pass array, so it is passed by reference. But in swap function, when we call swap function, we will pass one element. Okay, and that one element is actually called by value. Now in this we will we will see that how we can convert a variable which is called by value to make it pass by reference. Okay, so let's see the example first of bubble sort, then we will discuss in detail, right? Okay, so this is the function. So we are calling bubble sort. Now in this, please remember that we are explicitly declaring that array is a constant pointer of integer type. Okay, so along with this, we are also passing the size of the array. So this is our array A. Okay, we have made the size as a symbolic constant, and the type of I is size t, okay, which is equivalent to unsigned integer. Then what we are doing is we are printing the original data of the array. We are calling our bubble sort function, and after calling bubble sort function, we are again printing the same array. Okay, this is only what main program is doing. Okay, we are printing the array. After that, we will call bubble sort, and then again we will print this array. Okay, right. Now let's see what bubble sort is doing. So this is the bubble sort function definition. Now bubble sort, inside bubble sort, please note that inside bubble sort we make a prototype of another what you can say function, okay, which is a swap function. Okay, okay, the prototype we will see discuss a little later. So in this, there are two variables that are required. One variable is the pass counter and other is the comparison counter. Okay, we will execute two for loops or nested for loops. Okay, the first for loop is for pass. Pass will go from 0 to size minus 1, and the other loop is for again for comparison, which will also go from 0 to n minus 1 or size minus 1. Okay, and then what we are doing is, if a of j is greater than a of j plus 1, then we will say swap, otherwise no need to do anything. Okay, otherwise we will call our swap function, and we are expecting that swap will actually swap the elements in the original array. Okay, we want the swap will actually modify the elements of the original array. Now, if we would like to do that, what we have to do, we have to pass the address of the array rather than simple array with the subscript. Okay, rather than the elements, we have to pass address of that element. Okay, and therefore this swap function, you know what it will take? It will take two pointers, because from the function we are calling two addresses, not the values. Okay, and this is how we can make any variable to pass by reference rather than pass by value. Okay, are you getting my point? Inside this, we just make a simple variable hold. This is a temporary variable, local variable. It will hold the value that is stored at element pointer 1. Okay, and element pointer 1 is some location of array, suppose a of j. Okay, and a of j plus 1. This is what we have passed. So this will hold actually the value of this. Then we will exchange the value. We will store j plus 1 to this location, and then again at this location we will store the value that is stored in hold. Okay, now when we are using pointer, it will actually change the original array. It is actually changing the original array. Okay, and therefore the data type, I mean the pointer here, the keyword here constant is not used, because we only want that the array pointer is should be constant but not the data. Okay, because we have to change the values of this data. So this is how you can do pass by or call by reference to any variable which is not by default called by reference. Okay, you have to pass the address when you are calling the function, and in the function declaration you have to mention the pointers. Any question in this? Yes, no?
Ma'am, may you show the previous slide?
Yeah, sure.
Okay, ma'am.
This is the bubble. Okay.
Yes, ma'am.
So, let's see, this part actually, right? So even though swap is not allowed to say this, so this is, if you write in this manner, this is call by value. If you want to convert this into pass by reference, what you have to write, you have to write. So this, both of these are having same effect. Okay. The only difference is, in the previous case, if you remember, we are actually doing all the things at the same location. We are not calling swap function separately. Okay, this concept we are writing inside main function only. Therefore the value of original thing is changed. But whenever you are doing function calling, then if you want the value to be changed in the original array, you have to write it in this manner, in the pointer manner. Okay. Do you like to see the previous program also for comparison? I mean the simple bubble sort that we have seen.
And इस
No, ma'am.
प्रोग्राम को लाइन नंबर 46 और 54 एक बार फिर से समझा दो.
Line number
46, 54. No,
कौन
मैम.
से
50. एक तो लाइन नंबर 50 समझा दो फिर से, जो हाईलाइटेड है.
Yeah, just a minute, right? Let me first show you the previous. Is this slide visible? No, I think, right? Okay, just a minute, right? Let me copy one program. Okay, this is the previous program. I mean, it's better to not do this. Yes, this is the previous program that we have looked at, okay? And this is how we do our bubble sort, right? We wrote everything in the main function. So we have started our main function. I hope it is visible now. Yes?
Yes, ma'am.
Okay, so this is our previous function. So what we did is actually we write everything inside our main function. There is no function calling. Okay, and these are the two passes that we will make. And yeah, these are the two passes that we will make. And then this is how we wrote our swapping program. So since we are writing everything inside main function, then there is no notion of whether the original value will change or not. But whenever you will make your program, whenever you start making your program modular, what will happen is you have to pass it, you have to pass the controls to some other function. And whenever you have to pass the control to some other function, all these privileges thing will come. Okay, whether you are, that function is allowed to make the changes or not, and all these things. So it is always good to have the modular program, okay, and have many functions in your program. But along with that, you also have to keep in mind that whether these functions are having proper privileges or not. Okay, so now let me explain you this line again. I think the highlighted line you are talking about, right? This particular line.
Yes, ma'am.
So in this, what will happen is this. See, array j, what do you mean by array j? Array j is a variable. This is not a memory location. This is a variable. Only array is a memory location. Okay, and why compilers say that only array or array 0 is actually the memory location? Why not other elements? So the reason is, always we know the data type of the array. Suppose the data type is integer. Now the compiler only need, and arrays are stored in a consecutive memory location. So if the array knows the address of first location, then it is sufficient. Then there is no problem, right? Because for all the other elements, the array can find itself what is the value of that. Okay, so therefore array element is considered to be a variable. So when array is passed, actually we are passing array address, but when we are passing any particular element along with the subscript, then the value will get passed. Okay, and since the value will get passed, what happen if we just pass the value? What the swap function will do, and there is no pointer. Okay, swap function will actually just swap element 1 to element 2. That's it, nothing else. Okay, no change will get reflected in our bubble sort function. If you want that the change is reflected in the bubble sort function, okay, so apart from this, now if you are having pass by value, what you have to do is this. You have to then assign those, you have to take that return value in your bubble sort function and assign it again. So it is of no use. Okay, it is better that you have write those concept in your bubble sort function only, right? So now, because you want the change to be happen in the bubble sort function, what you have to use, you have to use pointers, right? And since we are using pointers, we cannot pass values, we have to pass the address of that value, and therefore we are using %, along with the variable name. Okay, even if you are having a simple variable, what you have to do, as I think somebody has asked in the previous slide, even if you want to pass a simple variable, suppose int x5, now you are calling some function, say square function, right? You have to pass %x. Okay, and in the declaration of the square function, what you have to do, square, you have to take a pointer of, suppose, int type, any name, y, and then you will say y into return y into, or just perform y into y. Okay, star y into star y. Okay, this will actually give you square, and then if you print the function, it will actually print the value. If you print x here, okay, I'm just writing a sort of a pseudo code. If you print x here, then it will print the square of the x. Why? Because you are passing the address, so it looks like y is pointing to x, 5 is stored, and then we will say that at this value, what you have to do, you have to multiply these 2 times and then store. So actually what it will get stored, 25 will get stored here, and when you print x, it will print 25. Okay, so using %, and address and asterisk operator, you can do call by reference or pass by reference to any variable.
मैम जब
Yeah.
हम पास बाय वैल्यू करते थे तो इसकी जो पूरा जो लिखा है स्वैप के अंदर जो वेरिएबल का नाम, वो वहां पर जाके लग जाता था, जो उधर मतलब जो दूसरा फंक्शन कॉल है, यहाँ पर इंट के बाद जैसे फर्स्ट वाला एलिमेंट है, पूरा उससे रिप्लेस हो जाता था. तो यहाँ पर भी रिप्लेस हो रहा है या कुछ और हो रहा है?
No, actually what happened is here, so element 1, right, is pointing to whatever location, right? Suppose, so this is our array. Okay, this is our array. Now at any point we are pointing, suppose we are saying that these are the 2 locations on which I would like to work with. So element 1 pointer is pointing to jth location and element 2 pointer is pointing to the second consecutive location. Okay, this is how we are passing the things, right? J and j plus 1. Right? So what it is doing is it is actually swapping the values. We are calling swap function only when we have to swap the values. Otherwise, we are not calling the swap function, right? So it is actually changing these values. Okay, because our star pointer is pointing to this location and asterisk 2 element 2 pointer is pointing to this location. So whenever we are changing the value, it is actually happening in the original array. This is what you are asking?
हाँ मैम, मैं ऐसे पूछ रहा था कि जैसे हम पास बाय वैल्यू करते थे जब, तो जो कॉल है फंक्शन कॉल, उसमें जो एलिमेंट लिखा है उस जगह पर हम वो वाला एलिमेंट लिख देते थे जो ऊपर वाला लिखा है, जो मतलब ऊपर हमने जब फंक्शन कॉल है वहां पर जो लिखा है वो वाला एलिमेंट हम इसकी डेफिनेशन में लिख देते थे नीचे, int star element ptr.
Give you a concrete, let me talk with the concrete example actually, right? So you are talking about the pass by value. This is what you are saying?
Yes ma'am.
Yes. Okay.
तो
So what?
तो जो फंक्शन की डेफिनेशन है int y मतलब उसके पैरामीटर, तो y की जगह पर x आ जाता था.
No, these are two separate variables actually.
अच्छा, ठीक है.
And this line means that x is a location in the memory, y is the location in the memory, and when we are doing this thing, it says y equal to x.
Okay, ma'am.
Okay, only we are talking about the values. Okay, so if 5 is there, 5 will get into y.
Okay, ma'am.
Any other question? Okay, now let's see, there are many features which we can look into this bubble sort. So if you notice that, we have used int asterisk constant array rather than simple array to indicate that bubble sort receive a single subscripted array as an argument, right? The parameter size is constant. We have make it as a symbolic constant so that nobody can change the size of the array, right? Because there is no requirement to change the size of the array. Now the prototype swap. Now this is a little bit important thing that is new to you. The prototype swap is included in the body of the bubble sort. Okay. So because bubble sort is the only function that is calling it. Okay, bubble sort is the only function that is calling it. Therefore, this prototype we are defining inside the body of the bubble sort function. Now, what is the use of this? Let's see. Now, placing the prototype in bubble sort restrict proper call of swap to those made from bubble sort. Okay. If other function would like to attempt or call the swap, it do not have the access of proper prototype. Okay, what is the return type? What are the parameters? So compiler will generate one automatically, and this will actually result in some sort of compilation error. Okay, so if you want that security as well, that much security as well, try to write the prototype inside the function in which it is only get used, to avoid other functions to unnecessary call swap function and make the changes, because the reason is this % sign. Okay, since in the swap function we are actually passing the address of our original array, and you will see that there are many attacks which are happen on the address, on the memory locations. Okay, memory related attack, memory hijacking attack. So it is always advisable to don't give the address of the actual array, but if it is required, you have to maintain proper security. It is just like giving your home address to someone. Okay, if you are giving the access to your home address to someone, it becomes vulnerable, right? So you will give your home address to only to the known person, not to everyone. Okay, so this is something like that, right? So since we are giving, we are passing addresses in the swap function, we have to secure our swap function as well. We don't want that any other function in the program will unnecessarily come and call the swap function and do, malified changes, something like that. Okay, so to have a secure programming, you have to maintain this privilege thing very, 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 precisely. You have to define all the things, right? So if other function attempt to call the swap, it do not have a access of proper function time, and therefore compiler will take care that it will not access our call function, the swap function exactly, right? So placing function prototype in the definition of other function enforces the principle of least privilege. Again and again I am talking about the principle of least privilege, बिकॉज होता है कि जब पॉइंटर्स हम यूज करते हैं तो बहुत सारी प्रॉब्लम्स, right, buffer flow problem, and there are many attacks that you will learn during this btech course in different subjects. There are many attacks that are possible due to this pointers and addresses of the memory. Okay, and therefore this principle of least privilege is important to know about, that how we can restrict proper function calls when we are calling other functions. Any question here? Yes. Okay. Now there is one more observation, and let's have a look at that observation as well. So, function bubble sort receives the size of the array as a parameter. Right now, there are many questions that you can ask here. Okay, one question could be that can we make the size as a global variable? Okay, and why to pass the size also during the array? So we are doing the sorting thing, right? Why to pass the size also? Okay, so when the array is passed to the function, the memory address of the first element of the array is received by the function. Okay, now this address actually does not convey what is the size. Okay, it only conveys that here is the starting of your array. This is where the array is started. We don't know that how many elements are there. We don't know what is the size of this array, etc., etc. Okay, and therefore we need to pass the size also along with the array, right? So this is the first thing, that we have to pass the size. Now another common practice is to pass pointer to the beginning of the array and pointer to the location just beyond the end of the array. Okay, so in the main function, when you are calling, what you can do, you can pass the first element address, and you can pass the last element address. And when the function, if the function need the size of the array, what it can do, it can subtract this from this, something like that. Okay, and it will know that what should be the size of the array, right? So this also can be used if you don't want to pass the size, but it is always advisable to pass the size also as an argument. Why? Because there are two main benefit of this approach. The first benefit is software reusability. Suppose this swap function you would like to use somewhere else. Not the swap function, the bubble sort function we are talking, right? So suppose this bubble sort function you would like to use somewhere else in your, in your program or in your software. Okay, because sorting is always required. So it may happen that, the companies will make modules of important things, that important operations that will be going to use again and again in the software development. They will make modules of that, thoroughly cross check it that there should not be any error in this particular small module, and whenever required they will just plug and play these modules. Okay, so this is called software reusability, right? Once you make a program of sorting, then no need to make it again and again. You can reuse this particular function, you can call this particular function whenever needed in your entire software development phase. Okay, so this is software reusability, and there is a proper software engineering, because we are making a module, we have tested that module properly and all these things. So the function should be complete in itself, right? So when we are defining the function which will receive array size, it will actually enable us to make the function that can be used in any type of environment. Okay, so we are actually increasing software reusability and proper software engineering. Now you can say that, uh, this could be a global variable. The size could be a global variable. Okay, and it could be accessed by the all the functions that are written in this file. But if you do so, then it may happen, that software reusability is of no use, because you are defining the global variable into one file. It might be possible that whenever this bubble sort is called from some other file, the access to this global variable should not be there. Okay, so therefore, whenever you are making a program, please make sure that the function that you are making should be complete in itself. And therefore, we are passing the size argument also along with the array name. Yes, any question? Okay, I hope there are no questions. So global variables usually violate principle of least privilege, because again we are allowing the access of something to everyone, and this can lead to poor software engineering, right? So global variable should only be used whenever it is truly required. Okay, whenever we want to share something to the entire program, then only we need such things. Okay. Any other question? If not, we can move to the second concept, a very small concept, that is size of operator. Okay, so C provide this unary operator size of to determine the size of an array into bytes, right? We have already seen this a little bit. Now let's discuss it in a bit detail. Okay, so whenever we define size of operator, what actually it will return? It will return total number of bytes in that array. Okay, so if our type of variable is float or int, okay, the computer store 4 bytes for this type of elements, or for this type of data types, right? So if the array is having 20 elements, and if we perform size of operation on the array, what is the output? The output will be 80. Okay, because the output is in bytes, right? So 20 into 4. This is what the function size of will return. Okay, so it is always good to use size of operator, because it is a compile time operator, and therefore it will not incur any execution time overhead. Okay, so when we write size, we will see the example actually. Yes, this is the example. So suppose in this, what we are doing is we are making a get size function. Okay, this function will give us the size of something, whatever we will pass inside it. Okay, now there is an array of 20. So size is a symbolic constant. We have declared an array of size 20, and the data type is float. We are printing two things: the number of bytes in the array, and the number of bytes are given by this particular thing, size of array, and then number of byte returned by get size function. We will see what get size will return. Okay, in get size, what we are doing is this: we are doing a pass by reference. So we are saying that, okay, there is a simple pointer of which will actually pointer to a float type data type, right? And this is pointing, so ptr is pointing to array. Array is having 20 elements and all, right? But pointer is pointing to this array. If we say what is the size of this pointer, what is the size of this pointer actually? What is the output of this function? Okay, let's discuss that first. What is the output of this program? Yes, What is the output? Am I audible? Yes.
Yes, ma'am, audible.
Yeah, so this is the output actually, right? The number of bytes in array is 80, but the get size is returning 4. Now, can you tell me the reason of this? What is the reason? Pointer is a simple variable which will actually store the address. Okay, and it is pointing to float type. So for this address storage, we only need 4 bytes. Okay, but array is actually having a larger size. So this get size is actually returning the size of the pointer, not the array. But size of array will actually return the size of the array, right? So size of the array is 80 because there are 20 elements. Each element will take 4 bytes, so 80 bytes. But size, get size will return only 4 because we are taking the size of the pointer only. Okay, the pointer variable only. Yes. Now, so the number of element in the array also can be determined by size of operator. How we can do that? Suppose you want to know what are the number of element, and this is one question that you will get into the exam as well, right? And this is a very logical thing to think of. Okay, how you can get the number of element using size of operator?
हम जो उसकी डेटा टाइप की वैल्यू है उससे डिवाइड करते हैं.
So this is the actually answer also in that, right? So size of not data type, actually size of the variable name. Okay, so size of real will actually give you how much. So double will take 8 bytes to store in the memory, right? Int float will take 4 bytes. So size of real will give you 176. Okay, because there are 22 elements, 22 into 8. And if you divide it by one element, this will give you the size of one element. So if you divide 176 by 8, which is the size of one element, you will know the number of elements. Okay, this is a very logical thing to do. Yes, no question? Question? Okay, so this is the use of size of operator. Okay. Okay, so this is a simple program. So I will just conclude my lecture by showing you this program. This is a size of all the data types. So in this program, I will share this program with you. These are all the data types that are possible: character, short, int, long int, float, double, long double, array, integer type array, and the pointer. Okay, and what we are printing is size of each and every character: size of char, size of short, size of, all these things we are printing depending upon the character, right? And we are calling it with each variable, and this is the output. Size of char is 1, s is 2, short is 2 actually, right? Integer is 4, long is 4, long is 8, float is 4, double is 8, long double is 8. Size of 20 elements, 20 into integer type, right? Yes, 20 into 4. Okay, will give you 80, and the pointer is 4. Okay, so I will share this program where you can have a look at what all the data types, how memory will store the size for, or how memory will reserve the size for each different type of data type. Yes, so with this, I will conclude today's lecture. If you have any question, you can go ahead and ask.
मैम
Thank you, ma'am.
मैम एक डाउट एक